transcribed into mRNA, and the mRNA is then translated into a polypeptide or a protein. In this video, we're going to concentrate on the translation aspect of this dogma. How does mRNA get read? And how does a polypeptide chain of amino acids form? Let's think of a simple scenario to help us out. A kindergarten teacher has a list of names that only she can read. She must form a line in the appropriate order according to the list. Her group of students cannot read and therefore don't know what order to get into and where to go. So, the teacher goes over, having read the names on her list and knowing where they need to go, and selects the appropriate child as the first person in line. The teacher helps guide the kid into the right order. Very similarly to this situation, Francis Crick had the same idea about something known as the tRNA molecule, pictured here and here. The tRNA, or transfer RNA, acts as a teacher in this situation, the guide. It grabs onto the appropriate child, or the amino acid, according to the mRNA, and brings it to the ribosome, where it enters at the A site, it links its amino acid at the P site, and exits at the E site. The definition of an adapter is a device for connecting pieces of equipment that cannot be connected directly. The tRNA, in this case, acts as an adapter between the mRNA code and the amino acid. The anticodon on the tRNA, shown here, determines the appropriate amino acid that binds to it. This anticodon base pairs with the mRNA sequence, the codon, and then deposits an amino acid into the growing polypeptide chain. Errors in translation can occur. For example, if the tRNA binds to the wrong amino acid, the polypeptide chain will not be the same and the protein might misfold. In this scenario, we have a chain of polypeptides that forms a protein like so, and another chain with a different amino acid that forms a chain like so. This chain is completely disfigured and might alter the processes in the cell.